this is step support assignment number 23, and can I just say before we start this, what an absolute breath of fresh air this assignment is. This is a wonderful question, and I am going to do almost no maths. How incredible does that sound? Anyway, let's get started. So the equation of a circle, this is this, where t is a positive number, show that c touches the line. So this is a circle, we can recognize that, right? The equation of a circle is this, where AB is the center, radius is r. So this is describing a circle with center 2t, t, radius t, I think. And I can draw a couple of those, right? If t is 2, then the center is 4, 2, radius 2. And notice how the height is 2, so the radius is 2, so it means this touches the line here. And if t is 4, then the center is 8, 4, radius 4, which means you put a center at 8, 4, and the radius is 4, which means it touches the y-axis again. So show that c touches the line y equals 0. Well, I think I can just do that by drawing a general picture. The center of this circle is 2tt. The radius is t, but I could just draw the radius going straight down, which is also t. And now the height of this center is t, the radius is t, which means, of course, it touches the y-axis. Or, not the y-axis, the x-axis, which is the line y equals 0. No maths required. Excellent. Next part. Let alpha be the acute angle between the x-axis and the line joining the origin to the center of C. So I'm going to have an alpha in here. Show that 2 alpha equals that and deduce C equals this. Okay, sure. So, got an angle of alpha here. Now, if I complete this triangle here, if I complete that triangle, this is t as discussed, both from this height and from this radius, that's t. This length here is 2t from that point there. So that's 2t. And now tan alpha is opposite over adjacent if this is a right angle triangle, which it is, because that's a right angle there, which means tan alpha is t over 2t, which is a half. And now this is the most complicated maths I'll be doing today. Here's the formula for the double angle form rule for tan. If you're doing step and if you're doing further maths, you kind of just need to know this off the top of your head. But this is great because I know what tan alpha is. It's a half. So I'll put that straight into there. 2 times a half is 1. So the top is 1. 1 take away a half squared is a quarter. Well, a half squared is a quarter. Then 1 take away that is 3/4. I've got an integer over a fraction, which means the denominator of the fraction can just bounce up to here to get 4/3. And that's literally how I think of it. I always use the word bounce. So it's 4/3. So what I've discovered here is that tan of 2 alpha is 4/3, and that's that bit of the question. And deduce that C touches the line 3y equals 4x. Well, why would I do any maths here when I can just continue to draw pictures? I think that this length here is t across there. This is a right angle as discussed, which means if I draw another tangent out, tangents meet radiuses at right angles by definition. And now here's a tangent meeting another tangent, which means this distance here is the same as that distance there, from GCSE tangent circle theorem rule. So look at these two triangles I've made, this lower one and this upper one. I think they're congruent because we've got equal side, and of course a shared side, which is equal. So these two triangles are congruent by SSS, which means this angle here is alpha, which means this entire angle is 2 alpha. And if I remove all the fluff of the question, I'm just left with some axes and an angle of 2 alpha and a line, right? So I've just removed all the fluff. This angle is 2 alpha. There's the line with the axis there. Now, I've just discovered earlier, and the question gave me, that tan 2 alpha is 4/3, which means the ratio of this line to this line is 4/3. Because, again, just using this rule, in this triangle, tan 2 alpha is 4/3, opposite over adjacent, which means the gradient of this line is 4/3. Which means the equation of the line is 4/3x plus c, but c is clearly 0, which means the equation line is 4/3x times both sides by 3, and we get that the circle touches the line 3y equals 4x, which is this line here. Okay, part 1 done, mate. Part 2, find the equation of the incircle of the triangle formed by the lines these, blah, blah. Let's draw a thing. That's the line y equals 0. That's the line that we were just discussing, 3y equals 4x. And let's draw this line out. Well, let's do a bit of rearranging. Oh, this is complicated. Okay, there it is. So let's draw this line. Well, it has a y-intercept of 15/4. I think I can work out when y is 0, 0 equals this, times everything by 4. I think eventually you solve that x is 5. You can do that on your own. And so this is the line here, right? There's the equation of it. Now, I might also want to note that this gradient, remember, was 4/3, this line's, and this line's gradient is -3/4. So these two lines are actually perpendicular. So there's a right angle in there. And that's the kind of thing that you want to just kind of be spotting. on questions like this, because you never know, that could really help you out. Okay, now the incircle of a triangle is the circle totally inside the triangle, which touches all three sides. So this circle then, with center here, and now we know the equation of a circle. It's this. We've looked at it before. With center AB, radius R. Okay, and now I'm just trying to find the equation of this circle. So I just need to find A, B, and R. Right? Well, but look at this. This is the same as part one, the very first thing we did. I can just change the R to be there, in which case, because this height is B, because that's what this coordinate means, but the radius is R, that means B is equal to R, which means I can refine my equation to be this, and now I'm only looking for two things, right? So that's a good start. Next, I'm going to say, well, look at this blue line again. That has gradient, or sorry, that rises for every three that it runs across. And so if I call this angle down here 2 alpha, tan of 2 alpha is now 4/3 because this gradient always goes 4 up for every 3 that goes across. So I've got, you can imagine a triangle in here of 4, 3, so tan 2 alpha is 4/3. But we've been dealing with this before, that was in part 1. And if tan of 2 alpha is 4/3, we worked out that tan of alpha is a half. In fact, we actually did it the other way around. We showed that if this is true, this is. But of course it works both ways. So I know that tan of alpha is a half. Now why is this important? Well, because I can split this angle here into an alpha just down here with a line going through the center of the circle there. Now, why can I do that? Well, remember what I did last time. It's because this triangle here is congruent to that triangle there, because they both just have side length r here. This tangent and this tangent are equal up to the point they meet, and they share a side. So that triangle there is congruent to that triangle there. Oops, to the blue triangle there. They're congruent, which means there's an alpha here and an alpha here. Of course, it was 2 alpha altogether, so this is just alpha. But now look what I can do. I can say, well, this length here is A, which means tan of alpha is R over A. But I know tan of alpha is a half as well. So that means a half is equal to R over A, which means R equals 2R equals A, which means I can replace this A for a 2R. And in case you've been shouting at the screen going, oh, sir, that's so obvious, we just did that. I know we did. We just did the example where this line and this line meet a circle at tangent, and we knew it was this form. So I could have just said that without doing any of that work, but I've been enjoying drawing these pictures so much that I decided to do it again. Anyway, which is the bit that we haven't used yet? We're just looking for R. There's one thing that we haven't used, which is, of course, the green line. So let's look at the gradient of the green line. That rises 3 every time it runs across 4. Right? So let's call this angle down here 2 theta this time. And now I can say, well, according to the tan rule, tan of 2 theta is 3 over 4, because this line rises 3 every 4 that it runs across. So tan of 2 alpha is 3 over 4 on this line. Okay, well, using this rule, again, for the second time, I think I can put in 3/4 into here and try and solve for tan theta. So cross multiply, rearrange, and now this looks a bit like a quadratic, and wouldn't it be great if it was a normal quadratic like this, with the same coefficients? Because this quadratic is great. We did these in like year 8. You can factorize them, and then you can solve it really easily. Well, actually, this is the same thing, right? All I have to do is factorize it with the tans inside. Right, it's the same idea. Okay, this is good, because that means either this is equal to 0 or this is equal to 0. Which means either tan theta is a third by adding 1 divided by 3, or tan theta is equal to -3. Now, which is it? Because it's only one thing. Well, notice how 2 theta is an acute angle, which means theta is definitely an acute angle, right? Now, looking at the tan graph, acute angles, tan of acute angle is a positive number. So it's not going to be this. So tan of theta is this, I can now say. And again, I'm going to make the same argument. If that's 2 theta in there, I'm going to say theta is just the thing that splits this with a line that goes to the center. And the reason I can say that, once again, is because this triangle here is congruent to this triangle there. Because they both have a side length of r here. This length is the same as this length, which means they're congruent, and this angle must be equal to this one. So this is a theta, so they add to 2 theta. But I need this as a theta because now look, I've got a triangle here, and I think this length here is 5 minus 2r, I think. Because there's a 5 minus the 2r, because this length is 2r. Okay, but now I can say tan of theta is r over 5 minus 2r. And now I have two descriptions for tan theta, which means a third is equal to this. Cross multiply, add the thing on, solve, and we know r is 1. And yeah, that was a joy of a question to do. Would have loved that in a STEP paper.